from your favorite artist, electronist, here in Romania. Alright, what I did here, I did something quite important, and I also worked for 10 or more days, probably 2 weeks, on this circuit alone, because first of all, when I'm simulating this circuit, this 4 guys here that you see these are called logic probes, and they are fine here in the simulator, but in reality you have to actually build a circuit to show the state of the wires, including putting some transistors on the outputs, or if the chip itself is powerful enough, it can drive directly the LEDs, but it's not the case all the time. So this is what I did here. I'm putting some LEDs to count, to see the counting, and these are the LEDs. They are custom LEDs that I made. This is the second version of them, and I had some problems with them, but they are still working here in this specific circuit that I have right now. Let's play it a little bit. It's set to automatic right now to here to a counter, automatic counter. On here on the right side, you can see them running through until reaching number 7, because this is how I set it. Actually, it's number 8, but it's counting to 7, it's reaching 7, and then when it's getting to 8, it's resetting back to 0. So it's 7 and 8, that 8 being 0. All right. So let's stop the simulation manually. So now it's on 0, it's starting on 0, it's starting normal. 0 and 16 have the same circuit actually. I started with 1 when I built the entire circuit. I started with 1, and when I reached 16, I couldn't see the LED, or I had some trouble, and I had to include the 0, and then these two got the same result, because it is the end of the counting of the chip. That's why. So I've also included the 16th, which is a bit. I will think about it if I will leave it or not, because from 0 to 15 is actually 16 pins. The 16th pin here is actually the 17th if we are counting 0. But yeah, I did it anyway like this, and it's a good hint that is the end of the counting, or the start of the counting when they both lit, is both beneficial and not so much. So right now let's count manually when I'm pressing this button here, this guy here. So right now is 1, and is lighting number 1 there. Let's see. Oh, good, perfect. Caramba. Like this. So now 2, and is switching to 2. Also, you can see here, you can look. Let me point you very precisely. Look here. Actually, let me go like this. Like this. This is counting in binary, and you can actually see when this is binary here, it is transformed here on the right side. Here, it is transformed into decimal, pretty much. Let's count. Let's continue in counting. 3, and here is the binary 3, and here is the actual decimal 3. Okay. 4. Again, here is the binary 4. So this is the binary 4, and here is the decimal 4. And 5 and 6, and now 7. You see it? So this is 7 here. Is the LED is lit. It's not that obvious. Maybe for some people it's not, and I don't like it very much. This kind of faint green lit. When I made the LED, it was very sharp, but here I don't know. When I'm actually using it, not so sharp anymore. For some reason, I don't know. When I tested them, they were looking fine. Probably they screw around. And this is the binary. Let me do the bigger. This is the binary 7 here. And pretty much now when I'm switching to 8, it's actually resetting to 0. So this is counting 8. Also pay attention here. This LED is lit now, and also what are you? And also this LED, and the two resetting LEDs are lit. And also this binary counter also is back reset to 0. So everything is working as it should. And this is the wire. This is the wire that is going to this connection here to make this counting to 8 all the time. Let's make a count to 16. This is 15, like this. This is for 15. So, but this, when I'm putting to ground, is 16, if I remember right. LEDs here, motherfucker. Shit. 1 second. Maybe do its business. Everything looks okay. Motherfucker. Motherfucker. Alright, so I had a bit of problem. So number 16, to make a count to 16, to number 16 here, I need this. I need to make this arrangement. So putting R0 to ground like this, and unlinking this resistor from the positive. So let's automatically make a test, and everything is working fine. Let's do, because this is a bit quick, a bit fast. Let's stop it, switch it to manual. So pay attention here in this sector on the LEDs. When I'm clicking on this button, every LED. So pay attention there. So right now, 1, 2, 3, 4, 5, 6, 7. Wait. Yeah, like this. Ah, so close. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So yes, this is counting to 16, and you can actually make a calculation in your head and see here on this numeric display, 48 is 16 times 3. So now it's 64, which is 16 times 4. And everything is working as it should. Let's see if I'm counting to 7. I'm trying to remember which one. I believe this one was. I remember 7 was having 3 links here. So this is hard coding the wires into how much I want to count. Okay. Let's count to 7 right now. And I forget something. I'm always forgetting it. So this is the wire that I have to cut out. And this is the logic that it must be for counting to 7 and stopping on 7 and resetting on 7. All right. But I'm always forgetting to cut this wire because 16th is the only number that it needs this pin to ground and cut this 1 kilo from plus 5 volts to high. But for the rest, everything is working with this arrangement. This in air, not connected to anything. And R01 to plus 5 volts through 1 kilo. Actually, in reality, is exactly inverse from the simulator. It doesn't work with 1 kilo here. Actually, it is working, but with erroneously, very erroneous results. I mean, these LEDs are not working. This part is not working at all, but it is counting erroneously. I can see it here on this LED on the latch on the flip-flop when I'm counting, when I'm testing the counter. So in reality, I have to actually do inverse. I have to link R0 to ground from 1 to 15, and the 16th I have to cut that wire, and I don't remember if I have to link this resistor to the positive on this wire particularly, but I know for sure I have to cut this, and it will work exactly inverse as it is here in the simulator. But that's not a big problem because I know all these things. I'm counting on them. I'm also counting, and I know exactly how it's doing in reality because I can count this output LED here. So now let's count to 7. Let's see, let's do it automatically, and it is. And let's 6, 7, and you can see here you can make the. I can reset it and start again now manually. So now it's starting on 0, which is excellent. 1, 2, 3, 4, 5, 6, and on 7 reset and starting again. Yeah, 3, 4, 7. Reset. And on 14th here, the numerical. But here in the simulator, it's easy to make some shortcuts from the reality. Here in the simulator, the idea is that you can visualize very easy, but in reality, you actually have to make a motherfucker circuit to actually display the outputs of all of this. Let me discuss a little bit the actual circuit that I have here. This part here, but not that part there. So only from these wires, these 4 wires here, these 4 wires are called the bus wires. Everything is there on those wires. Those are the data, if you want, the data wires. This section is the display area, the display circuit. This like that. This part is the logic, is the brain. Brain. No? That is thinking, that is creating the logic. This is the display for specifically for these LEDs, specifically for these LEDs here. This is the actual output, the actual display output. So this is what this circuit is doing, and for each display it has to be a certain number, you know, and a certain way of linking to the bus wires. And I have to make a parenthesis here. I had to explain something to someone, and I had to add this DS1 and DS2. They are not really important. DS1, it means diodes set. The set of diodes one, that is this is for the logic side, and I only did in reality I only made this number one display, and I've used this diodes set here, this arrangement for diodes, and also the LED for number 1 to display when I'm cycling through number 1. That's these two means what they are meaning. And also in reality, well, here in the simulator it worked with 100. Let's see, yeah, it's 100 ohms. But in reality, with 100 ohms, these resistors got extremely hot. And also the power supply for the entire circuit, and when I'm saying entire circuit, I mean the entire circuit, the total circuit here, was getting way too high because these were making a pretty much a short these resistors here. And the power supply got to 150 milliamps. When I'm not connecting, when I'm closing, when I'm doing this, when I'm disconnecting these resistors from these bus wires, the entire circuit is running to 10 milliamps, 10 or 15 milliamps, very low. But when I'm including these resistors, is jumping way too high because it's like a short, you know. But it is needed. Without them, all this displaying part is not really functioning. At least here in the simulator. In reality, it's not functioning at all. That's the the problem that I have in reality. I didn't manage to make it work in reality for some reason. But here in the simulator, as you can see, it's working absolutely perfectly. Another very important thing is that I added these PNPs. I've actually discussed this problem with a friend of mine, I think, and he suggested to add syncing and sourcing the current. And he actually looked on the datasheet of 7493, the binary counter, and he managed to observe there that this is syncing the current from better than setting the current. You know, so the inputs should surge through the chip and not from the chip to the outputs. You know, let me actually show you because I couldn't find this little detail and very important detail by myself, not in a million years. But this guy is very good with stuff like this. Like I said, I am an artist, but he is a real electronist, and all my respect for him. Come on. Actually, I have this forum thread here where I'm discussing this problem. It's solved. Here, what I have here, I originally used a 3-state buffer, as you can see the sign here. This 3-state buffer, and this actually solved my many permutations that I did. It wasn't easy to solve it, but let's find the data if I find it. And he suggested to look here in this section, exactly here in this section, and I couldn't by myself see this little very obscure detail, very obscure detail. Wow. So the output of current from this chip 7493. It is also saying here the name of the chip. This is 54, so that's not what I have here. I have 7453, but they are pretty similar. This is the 54. This is for the army, actually, the military. This is better than this. This is the commercial 74. All right, if I'm putting positive here, so this is positive, high level output, I will get minus 800 microamps, which is less than 1 milliamp. It's less than one single milliamp. But low level output current. But if I'm putting here a negative, so a negative here on this line, I will get 60 milliamps through the chip. So this is very interesting, and I couldn't figure it out by myself alone. Again, I'm an artist, and I don't really see everything, but I'm learning. And yeah, this is my friend idea, and it worked based on his idea and on his explanation that this chip must surge the current through it, and that's why PNP will BJT PNP transistor will be more suitable to drive the output pretty much. So that's let me actually open another file counting output, because this is version 2. This is what we have seen so far. This is version 1. In version 1 I have so many stuff. This is the maximum of this program, this square. Let's see, system. So you see 64 inch by 64 inch, and it is maximum. More than this is giving me an error. If I'm making this 66, it'll give me a value by not in range 1 inch to 64 inch. It only expects 64 inch, and this is the maximum sheet size I can draw into it. And these circuits are very big, and yeah, I made several variants, and these are not that important, these parts, because they are tests. There I was a lot of annotations there. I don't remember if this was working. Yeah, it's resetting on 2 instead of 0. Yeah, I was having a lot of issues and problems, and that's why I put this very big label here, solve, to actually see the one that is working. Also this one with the PNPs here is also working. Here I was trying various methods. I've tried all of these methods with BJTs, NPNs, with AND gates, with op amps, with I didn't use the MOSFETs. I didn't try the MOSFETs. I only draw the idea of it. So all of this stuff that I showed you there, I tried here linked to these bus wires, and I couldn't get any good results. I got some resetting, some very but then I get this result with let me actually make it full. Let me check if this is running. It's not running. Okay, so let's play this guy here. As you can see, it's staying like a couple of seconds and then running, and I cannot actually use it. It's not running smoothly. It's not running fast enough, the simulator, because it's having a lot of stuff in it. I wanted to say shit in it, which is also true. Let's see. I think this is linked to number 5 here. Is to count until number 5. And let's see, 1, 2, 3, 4, and 5 reset. Okay, so this is 5. But let me make it to 15, not to 6. Yeah, to 16. Okay, to actually see everything. Come on, don't scroll around. So let's make this as 16th, and also put this here and cut that wire there. And pay attention again on these LEDs. On these LEDs, pay attention here. All right. I have a little bit of reset on the 8 here for some reason. I wasn't getting that reset before. Very strange. But the idea is that is working with the 3-state buffer here. And if you pay attention, you can see the output of the 3-state buffer is actually this gray square here, and also here, and also here. And only here is positive. You see, is plus. The plus red is plus, and blue is minus. So this is neither plus nor minus, the gray ones. And that's very important to actually make all of this circuit working properly. This gray, as you can see here on the components themselves, they don't get actually a negative or a positive. They only get a positive. They don't get both negative and positive. They only get a positive, and that's it. And this is like staying in the air, uncoupled, unlinked, cut out, which is very important. And this is how I could actually figure out how to build this thing. I was thinking on the third state of the third logic state, pretty much. And yeah, it is doing it until 16 with this arrangement that I have right there. Okay, this is what I wanted to show you. This is the version 1 actually, and let's see what I have here. Here also some troublesome, some trouble circuit. But yeah, actually I've tried. The first thing that I tried was to cascade some chips. I was thinking on cascading some integrated circuits, and in this case I was thinking on cascading 4017, which is very cool, very good IC, but I couldn't make it work. Actually, I can show it. I can show it to you what it's doing. Is doing this, and when it's cascading, it's switching to the next LED there, which is not really what I want. And then cycling through all these 10 LEDs here, and then switching the next one. Not really what I wanted. And then and I couldn't imagine how I could do it. And here I tried to make 4028 to cascade it, but I couldn't figure it out either. And actually, this I was testing it here. And then I tried with LM3914. I know this guy can be cascaded actually pretty well, and it didn't work at all. For some reason, I don't remember why, but it didn't. And okay, that's it. This is it with this circuit. Here I was trying various permutations to make it work. The displaying, to how to display it. And this is how it all begins with a very simple circuit, and try to figure out how to make it work. So this is more complicated with more transistors, and but this is more elegant with only the diodes in it and only one transistor for the reset. And yeah, I chose that one. They are both working actually. These two variants, they are both working, but one is more complicated, unnecessarily complicated than the other, and I get exactly the same results from both of them. Pretty much this is it, I believe. Let me close this save now. So we are back on the original testing circuit here that is working here in the simulator, but in reality is not really working to display, only the display part. So the displaying part is not working, but the counting, this part, it is working absolutely fine. And I can count here on this LED here, I can count actually each each wire programming set that I make, so I actually stayed and count to 16 and then back again and again to 16. I did all the numbers, I count them manually, and it took me a good amount of time to actually be sure that everything is working properly. So this is the counting circuit that I used. And for this here, as you can see it here, is an automatic, very small, very cute automatic counter here in the simulator. But in reality, let me go to that page and show you. This is my clock, my counter, my clock box. This is my counter here, which is having 3 wires, a positive, a negative, and a clocking signal wire there. So pretty much, yeah. And this is the test arrangement that I did. I've only, I only made for number 1 here to display number 1, and it didn't work in reality. I'm missing something. This simulator here is more forgiving in the simulator, and I'm getting false positives from the simulator, and in reality it doesn't really work. But the idea is good, because if it's working in the simulator, it should work in reality. In reality, I have to tweak something. I don't know what yet, what I have to tweak. But if I'm discovering what to tweak in reality, all the circuit that I'm having here in the simulator, it will work in reality as well. Very well, actually, it will work in reality. But until then, I will stop here because this is a long-ass presentation and a long-ass discussion and a long-ass project. And thank you very much for your attention. Thank you very much for watching and understanding all the very interesting and very hard point, because this was not an easy project. This was a very hard project actually. Thank you very much, and see you later, I suppose. I guess. I hope. Yeah. Thank you very much. Bye bye.